Hello everyone, I'm Ethan, and today I will be sharing this cybersecurity presentation along with my group mates, Caden, Jayden, Neil, and Vincent. Today, we will be sharing 4 out of 7 of the cybersecurity domains. We have the system domain, data domain, network domain, and software domain. So, without further ado, let's have Jayden start us off with the system domain.
So firstly, I'll be going through the basic computer systems. Firstly, for hardware. The CPU acts as the brain of the computer that communicate with other part of the computer, such as memory that helps the CPU store data that's not being used at the moment. Input and output devices are external devices that can be connected with your computer. All of these components allows the computer to function properly and allow a pleasant user experience. For the software, it's split into system software and application software, which I will talk about later. For the system software, the operating system and the utility program. The system software is basically a software program responsible for running and managing your computer resources. And for utility program, it is designed to enhance the functionality of the operating system and provide additional tools and features for users. Next, I will go into brief detail about the application software and computer hardware. For application software, it basically refers to a set of computer programs designed to perform specific tasks. They are created to extend the functionality of the computer beyond its basic operations. For the computer hardware, it refers to physical components in a computer system. It requires hardware resources to power and execute its functions. The hardware components of computer provides the processing power, storage, input, output, and display capabilities to run the application software smoothly. The relationship between both is complementary. With adequate hardware and resources, most application software will run fast and efficiently. Next, I will be going through the Trojan horse. A Trojan horse is basically a malicious malware that is designed to damage file, monitor the user's activities, and steal important data. An example is when a Trojan horse attack is when you download a file you download a file into your computer which you think functions that way, but in actuality it functions another way and is used to steal your data. A Trojan horse can delete, block, and modify and leak your data and use them for their own gains. The hacker can use these stolen files to blackmail the user for money. Next, I will pass on the time to Caden to carry on the presentation.
Okay, thank you, Jayden. So now I'll be talking about data domain. While the data domain comprises of many things, I will only be talking about cryptography. So, what is cryptography? It is the provision of secure communications in the presence of malicious third parties. And what is it for? To keep information only to the intended users. Now, cryptography has been around for many, many years, since even the time of Julius Caesar. And over the centuries, many brilliant minds have come up with many sophisticated devices to encrypt information. Some examples include Caesar cipher, the Enigma, which I will touch on more later, and the RSA, a public key crypto system. Now, while these examples are not directly linked to one another, they are just used to show how much cryptography has evolved over the centuries. So, first off, we have the Caesar cipher. It is just a substitution cipher which replaces letters by a fixed number of times down the alphabet. Pretty simple. And then we move on to the infamous Enigma, the iconic encoding machine used by the Germans during the World War II. It uses 3 rotors to substitute the letter inputted 3 times before it gets outputted. So let's say I key in the letter A twice consecutively. Get 2 different outputs. That's crazy. And then we move on to RSA, a public key crypto system. Invented in 1977, it's pretty old, but mainly used for data transmission as it's quite reliable. And how it works is that it uses two keys, a public key and a private key. The sender will send information and encrypt that data using the public key, and the recipient will use his own private key to decrypt that data. So only the intended recipient will get to see what the message is. While that is an oversimplified description of how RSA works, due to time constraint, I cannot go further. So that is all from me. Now I'll pass on the time to Vincent.
So now I'll be talking about network security. Network security consists of practices to prevent unauthorized access of a computer network and network accessible resources. There are a lot of different network protections. However, I'll only be talking about firewall, intrusion prevention system, and honeypot. Firewall acts as the first line of defense. The most common location to put a firewall is at the network perimeter. Deploying a firewall at the network perimeter defines and enforces the boundary between the protected internal network and the untrusted public internet. Next is the intrusion prevention system, which is a network security tool, which can be a hardware or a software, that continuously monitors a network for malicious activity and takes action to prevent it, including reporting, blocking, or dropping it when it does occur. It can take many automated actions, including alerting administrators, dropping the packets, blocking traffic from the source address, or resetting the connection. Should a malicious anomaly make it past the firewall, the most stringent IPS software can provide a last point of defense to stop a network breach. At the same time, while a firewall may not alert network administrators of blocked malicious activity, an IPS often does. Lastly, some people use honeypot as a way of protecting their network. Honeypot acts as a baiting trap for hackers. It's a sacrificial computer system that's intended to attract cyber attacks like a decoy. It mimics a target for hackers and uses their intrusion attempts to gain information about cyber criminals and the way they are operating, or to distract them from other targets. Next, we will be moving on to the software domain.
Software domain. Cybersecurity in the software domain is the concept of implementing mechanisms in the construction of software to prevent attacks. So basically, what this means is cybersecurity in the software domain is covering up and preventing any vulnerabilities in everyday software such as Microsoft Word, Spotify, and many others. Common software vulnerabilities include missing data encryption, injection flaws, and unrestricted upload of file types. Missing data encryption means that any data used by the software can be leaked and any hacker can use that data to gain access of bank accounts and identity of any employee or customer. This can lead to identity theft, where the hacker can open a bank account using your name and take out many loans. For injection flaws, a hacker can relay code through the input of any software. This allows them to take over the software and access any back-end data of the server used by that software. For unrestricted upload of file types, any hacker can use their own file type that they made themselves and use it to overload the file system and create a complete system takeover of the back-end data servers. Next to Ethan.
We have come to the end of our presentation. Thank you for your kind attention, and we hope that this presentation has taught you something new.